We've been scanning the sky for signals since 1960. 65 years of listening. Radio telescopes the size of football fields, pointed at billions of stars, running around the clock. And so far, silence. That silence gets stranger the longer you think about it. 2 trillion galaxies, each with hundreds of billions of stars. And most of those stars have planets. Not some of them, most of them. The Kepler telescope alone found over 2,600 confirmed planets in 9 years, watching a patch of sky the size of your fist held at arm's length. One fist. 2,500 worlds. Scale that across the entire sky and the number becomes impossible to process. Planets aren't rare. Planets are the default. The real question isn't whether other planets exist. It's whether anyone is on them. And science's answer is neither yes nor no. Life needs 3 things: liquid water, an energy source, and carbon-based chemistry. Sounds rare. But in 1977, oceanographers sent a submersible to the bottom of the Pacific near the Galapagos Islands. In absolute darkness, they found cracks in the seafloor with water bursting out at 400 degrees Celsius. And right around those cracks, life, tube worms 2 meters long. Shrimp with eyes on their backs. Bacteria thriving where nothing should exist. That discovery broke a rule we'd followed since Darwin. Life doesn't need the sun. It only needs chemistry and heat. Which means the most interesting places in our solar system aren't Mars. They're the moons. Europa, one of Jupiter's moons, hides a global ocean beneath 15 to 25 kilometers of ice. Scientists calculated in 2023 that ocean goes down 100 kilometers deep. The entire Pacific is 11 kilometers at its deepest. On the floor of that ocean, there are almost certainly hydrothermal vents, the same chemistry, the same heat, running without interruption for 4 billion years. In October 2024, NASA launched the Europa Clipper spacecraft. In 2030, it will reach Jupiter and analyze water plumes bursting through cracks in the ice, searching for organic molecules and any sign something could live there. Then there's Enceladus, a moon of Saturn. In 2005, the Cassini spacecraft flew through one of its geysers and found hydrogen, silica particles, and complex organic compounds, exactly what you get when hot water reacts with rock. Hunter Waite, one of the lead scientists, said in 2017 that Enceladus ticked every single habitability criterion they had. Every one. Nobody is claiming they found life. Because between conditions being right and something actually being there, there's a chasm. We still don't know how life begins. In 1952, Stanley Miller and Harold Urey at the University of Chicago filled a flask with gases thought to make up early Earth's atmosphere and ran electrical sparks through it. After a week, the water turned brown. Analysis revealed amino acids, the building blocks of proteins, life's raw ingredients, created in 7 days from gas and electricity. The experiment has been repeated dozens of times. The result is always the same, which raises a question unanswered for 70 years. If triggering this chemistry is so easy, why hasn't it triggered everywhere? This is the Fermi Paradox. In 1950, physicist Enrico Fermi made a calculation at lunch that has troubled science ever since. The universe is 13.8 billion years old. There has been more than enough time for intelligent life to arise and spread. The galaxy is 100,000 light-years across a civilization with moderate technology could colonize the whole thing in a few million years. So where is everybody? One answer is called the Great Filter, proposed by economist Robin Hanson in 1998. Somewhere between chemistry and an interstellar civilization, there's a barrier so lethal that almost nothing gets through. Either it's already behind us, the near-impossible jump from bacteria to complex cells that took 2 billion years on Earth, or it's still ahead. Every civilization destroys itself before spreading. Nuclear weapons, engineered viruses, climate collapse, its own capabilities outrunning its wisdom. Stephen Hawking spent years arguing we should stop broadcasting our location into space. When Europeans reached the Americas in 1492, They brought diseases that killed around 90% of the indigenous population within a century. Not out of malice, simply from contact. But there's a third explanation. What if we simply arrived too early? Heavy elements needed for rocky planets only became widespread about 8 billion years ago. Earth formed 4.5 billion years ago, fairly young by cosmic standards. Astrophysicist David Kipping at Columbia University calculated in 2021 that we may be among the first 8% of all civilizations that will ever exist. The other 92% haven't been born yet. Then in 2017, astronomers discovered a star system 40 light-years away with 7 Earth-sized planets, 3 in the habitable zone, TRAPPIST, 1. 2 of those planets have densities consistent with rocky, water-bearing worlds, 40 light-years on a cosmic scale, the house next door. The James Webb Space Telescope began studying TRAPPIST 1-inch 2023. We're reading the atmospheres of alien worlds in real time. Because every living organism changes its environment, photosynthesis pumped oxygen into Earth's atmosphere 2.4 billion years ago. Life wrote its signature in the air. If Webb detects oxygen, methane, and ozone together in another planet's atmosphere, that combination is chemically impossible to maintain without biology. Finding all 3 at once is what scientists call a biosignature. Webb hasn't found that yet. But it's 3 years into a 10-year mission. And there's Mars. Not the frozen desert it is today, but Mars 3.5 billion years ago, with a magnetic field, flowing rivers, and an ocean covering 1/3 of the northern hemisphere. The Perseverance rover has been drilling core samples in Jezero crater since 2021. Those samples sit right now in sealed titanium tubes on the Martian surface, waiting for the Mars sample return mission. The planned return is the mid-2030s, 20 years of work, billions of dollars, and the answer may already be sealed in a tube on the floor of a crater 225 million kilometers from here. There's a version of the next 30 years where we find nothing, Europa sterile, TRAPPIST, 1 inert, Mars samples, blank. And there's another version where we find something microscopic, a chemical trace, a radio blip that holds up to every test. Because a dead microbe on Mars would mean life arose independently on 2 planets in the same solar system, which means it probably arose everywhere conditions allowed. 1 data point breaks the isolation, 1 confirmed case makes Earth an ordinary example, and the silence of the cosmos starts to look not like emptiness, but like a timing problem. We've been searching seriously for 65 years. The universe is 13.8 billion years old. We've been at this for less than a blink of cosmic time. With instruments a civilization 1,000 years ahead of us would consider toys. The experiments running right now, a spacecraft crossing the asteroid belt toward Jupiter, a rover grinding into crater rock, a telescope reading starlight through alien atmospheres, were designed precisely because both options are still possible. Either life here was a freak accident that may never repeat, or life is the natural outcome of conditions the universe produces routinely, and we live in a galaxy that has been running biological experiments for 8 billion years without our knowledge. Whatever the answer turns out to be, it will be the most important discovery in the history of science. If we find nothing that's a result, if we find something that changes everything. For now, the telescopes keep turning, the rovers keep drilling, and somewhere in that data, the answer is most likely already waiting. And think about what that actually means for us. Right now, in 2025, we are the first generation in human history with the tools to actually answer this question. Every civilization before us could only look up and wonder. We get to look up and test. The rovers are real, the telescopes are real, the data is coming in right now, today, while you're watching this. We're not waiting for the future is already running in the background. And whether the answer comes in 5 years or 51 thing is certain, the universe is under no obligation to be empty just because we haven't found anyone yet. Absence of evidence is not evidence of absence. We've checked 1 grain of sand on an infinite beach and called it a search. The real search has barely begun. And somewhere out there, around one of those trillion stars, something may already be asking the same question we are, looking out at the sky, wondering if anyone else is listening. The only difference is we started looking first.